capacitors is then we had little wires, if you will, represented by solid lines. So we'll continue to do that. We won't change anything. But what is new is the symbol for the resistor. We will just make it look kind of like a wire that's bent. You could imagine a bent wire or a pipe that it's got all these little knots and turns in it, and as it turns, it's kind of hard to flow through that. And so this is our universal design for a resistor. And so that's what's new here in this chapter in the lab. What is the symbol for the resistance? And maybe I'll just put a V over here for the voltage. So again, you've seen this and you've seen the wires, but this is the circuit that I am going to hook up. And so this is my push, this is my resistance, and so I want to see how much flows. And so right in here somewhere, I'm going to give you kind of a new symbol. This will be my ammeter. My ammeter measures the current. How much actually is flowing through this circuit. Okay? And of course, let me also hook and kind of make a similar looking symbol. Let me call this my voltmeter. And of course, we used those handheld voltmeters in the last lab we did. We're not going to use the handheld ones. We're going to use ones that interface to our computer here today. But that one I think you're already familiar with somewhat, and we will continue to use throughout the semester the handheld ones. And so we will have some handheld ammeters, not today, but coming up, and we will continue to use those handheld voltmeters. But today we have these special ones that talk right to the computer and send the data, and like I said, that's what makes actually collecting the data for the lab pretty straightforward. The circuit I want. Oh, here's my advice. And I'll give it to you even though you're not hooking it up, but it's probably good to you hear it because, you know, this pandemic will be over and you will, you know, continue on with your education, and hopefully you will be able to actually hook up these circuits on your own when you get that chance. And so my recommendation is always to think about the circuit without your measuring device. You might hear me say that with the capacitor. Let's just think about it first without the measuring device, and then let's add our measuring device at the end. All right, so in my mind, I'm going to ignore the voltmeter and the ammeter. I just need the power supply, some wires, and the resistor. So coming over to here, let's hook that up. So here is the power supply. Let me go ahead and start it with 0 voltage here. And if I look at my power supply, there's a plus and a minus. And if I come back and look at my picture, this is saying take the plus, take a wire, and I'll ignore the ammeter for a second and hook it to your resistor. So it looks something like this. So I'm going to take my wire and I'm going to hook it to the plus, and I'm going to go to my resistor. Now, my wires have these little banana jacks on them, so I put some alligator clips on here earlier, so I could just say, okay, there's my connection right here to my resistor. Let me get some of this other stuff out of the way so that doesn't confuse you. And so then as I look at it, the current is going to go through the resistor, and then from the resistor back to the negative of the power supply. And it's tradition to use a black wire for that. Maybe I'll just grab this one. Of course, it really doesn't matter what color the wire is, but it can sometimes help our thinking process. And so there is my circuit, if you will. I'll kind of hold it up here and say, okay, there it is. The current flows through the resistor and back. Okay? All right. So now let's hook up the measuring devices. Okay? So the measuring devices would be saying what's the voltage. And in fact, maybe I should do a better job with my picture. Not that this is wrong, but I think it will look better to you. And that's how I'll hook it up here. If I say that what I want to hook up is the voltmeter at the resistor, because I want to know how much I'm actually pushing on the resistor. Right? That's Ohm's Law. Right? If we come back over here, this is exactly my point of Ohm's Law, that I want to know how much am I pushing on the resistor. Together with the resistance of the resistor, those two factors determine excuse me, how much actually flows. So this voltage should really be connected to the resistor. All right, so coming over to here, and I kind of set this up a little bit ahead of time here. Let me turn my computer back on. But this is my voltmeter, and it goes through this interface box that I need to check. This might be backwards. I did not look at this ahead of time. I think let me just check. It says connect the voltage probe to channel 1. So if this is the voltage probe, yeah, this is backwards. And let me connect it to channel 1. And then the other one, which is going to be my ammeter, goes to channel 2. All right. So that's just how the software is set up. But the big thing I want you to see is right here. So here's my voltmeter. And so these two have these banana jacks on them. So I'll just connect my banana jacks here. And that voltage should be sent over to my computer once I get it started, and I'll do a little check there. So I would say I have connected then the voltmeter. Oh, by the way, a good phrase that you should learn, even though I know we're not doing this in class, but your day is coming, you should remember then that what we like to say are voltmeters are hooked in parallel. Voltmeters are much easier to hook up than ammeters. You're going to see that here in just a second. The voltmeter, you just literally just connect on. You just come around and you just clip it on, because all this little device is doing is measuring the energy on this side and the energy on that side. Because remember, voltage is the change in energy per charge. That's what a voltage is, a coulomb per charge. So they're real easy to hook up. You don't have to change your circuit. You just come up and clamp onto them. However, ammeters, I think, are a little bit harder to do. This ammeter, of course, is an electronic one, so it goes right to the computer. But whether it be a handheld one or an electronic one, this ammeter can only work when the current goes through there. So you can't just come around and clamp it on what we call in parallel, because that's not where the current is. It actually has to go through it. So the phrase we like to use is ammeters have to be hooked up in series. That's why if you looked at my picture, I put the ammeter right in the wire. And so what I really need to do to hook this up is to actually open up the wire and let the current go actually through the ammeter. Because the equipment inside is counting the number of electrons. You have to actually make it go through this equipment. So to do this right, I will probably need another wire here. So I'm going to grab another wire and hook it up. All right, so coming over to here, and let me just... And I'm going to have to temporarily disconnect the voltmeter to do this well. So I'll just temporarily disconnect that one. But see, the current was coming out of here, and so I'm going to actually just open the circuit right here, because that's the electrons that will be flowing through here. I'll feed it into the ammeter, and this is why I need another wire, so that when it comes out of the ammeter, it can continue on to that resistor. And so again, let me use that phrase. Ammeters are a little trickier. They have to be hooked up in series. I like to think of it this way. The ammeter is really measuring the flow. So the flow has to actually go through the meter. The meter can't work unless it goes through that. And once you understand that, you begin to realize, oh yeah, that totally makes sense why they have to be in series. And likewise for the voltmeters. The voltmeters don't have to be in series. The voltmeters is just like taking a measurement at the top of the waterfall and the bottom of the waterfall. You don't have to get in the waterfall. You can just go to the top and make a measurement. Okay, what is the energy at the top? Then you can go to the bottom and make a measurement at the bottom. You don't have to actually get in the waterfall. But if you want to actually make a measurement of the flow of the water in the waterfall, you actually got to get into the waterfall, and you got to put up an instrument that can actually measure how much water is flowing. And so ammeters are in series, voltmeters are in parallel, and that is what a good face-to-face in-class setting would do well, because inevitably you might hook it up wrong. And you will get a false reading, and you'll recognize that and go, oh, I'm not doing something right. All right, well, let me now finally get ready to do the lab. If you remember, I disconnected the voltmeter, so I'm going to reattach it. And I think now I have my circuits all hooked up, and I'll do a little test here in a second to make sure. But I've got the simple circuit. I'll come back here. Here's my push. Here's my resistance. It's going to flow through here. There's the ammeter that's going to measure how much is actually flowing. And there's the voltmeter that's going to measure how much push am I giving it. And these two, of course, will be fed into the computer. So with that in mind, let me put the display up here on the screen so you can begin to see what I see here on my screen. I need to start the right program here, and then point to a few things. Good. And maybe I will.
It's coming.
Oh, okay. A little delay there, but it's coming. And maybe I will start by, turning it off completely. And so now I have no power. But you'll see then that this instrument, if it's reading, I'll give it a little test here in a second, but it is reading the push, the potential, and it is reading the current. Now, of course, it's off, so these should be reading 0, which they're not quite reading 0. So before I begin, I'm going to what we call zero the probes. That is, I'm going to tell the computer that right now it should be reading a 0, and so recalibrate all of this good stuff and give me a 0 reading. Okay, so sure enough, now it gave me a 0 reading. Now I'm going to turn on my power supply here, and let me just see and double check that my probes aren't backwards. I'm just going to turn up the voltage here a little bit, and I'll use the one on my power supply which says it's at about 2.1 volts, and come over here and sure enough, it's reading a 2.1 volts. So I think I got it in the right connection. As well as it is reading a current. Now I don't know if that would be the right value or not, although I will tell you, if it is 10, then 2.1 divided by 10 is 0.21 there. So that's telling me that the resistor I have is a little bit more than 10 ohms right now. But there's my reading. So here's what I was saying about whether it's in class or online here. Let's collect a bunch of different voltages and the corresponding currents, and then just do this test. And here's the test here. I'm going to collect different voltages, I'm going to collect different currents, and then I'm going to make that plot. All right, now before I begin to collect the data, and I'll just bring my mouse a little closer, let me change the horizontal axis to roughly, let's just go 0.6. Okay. Because I know it'll be nice to see the whole thing while I'm collecting the data. If I didn't change it, we'd still get the same results, but we wouldn't see it while we're collecting it. So I will begin. And so some of you have used the Logger Pro, some of you have not. But it's a real simple. You just go to the green button up at top and hit collect, and it will start collecting data. And in this case, the computer actually then plots right here, this red, the current reading. And so I've got about 2 volts and 0.2. But let me not, what I'll call keep that. Let me just turn the knob all the way down. And hopefully you can see the red dot goes all the way to 0. So there's the voltage, there's the current. And all I got to do is click on the button keep. And it will put the current readings in the table. And so, like I said, if this was kind of a, in class 1, it wouldn't take you long. You just turn the knob a little bit up until you get some voltage, maybe right there, and hit keep. Turn it a little more, 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 hit keep. A little more, a little more, a little more. And every time you hit keep, it records it in the table and leaves a red dot on the graph. And like I said, this is one of the simplest labs to collect data, and we'll just keep increasing the potential until we get to 5 volts and call it done. Yay, and then click stop. All right, so here is your data. Looks like it went off the screen here. That's fine. But there is it already plot. There's the potential, there's the current. Does it have a straight line? Yes. So are we following this Ohm's law? Are we proving this Ohm's law? Yes. And as we said earlier then, if we were to measure the slope of this, in fact, I should have said not only is it a straight line, but it's a straight line that goes through the origin. Okay. But then if we were to measure the slope of this, this would tell us what that resistance is. So before I print it, I will highlight the data. Don't worry, I'm not going to actually print it. Ron was just telling me our printer's off. But I'm going to make a PDF, and that's going to send to you. Okay, so you guys are going to work on this. And if I were to turn on the slope, there it is. And I then have a slope of 10.26. And so I would say that this resistor, let me just turn this down for a minute while I'm talking, that this resistor is following Ohm's law. This is Ohm's law. And I've just confirmed Ohm's law. There is what we would call in mathematics a proportional relationship between the current and the voltage, and that's proportional to the resistance. And I now have just found the resistance of the blue resistor, 10.26, which is what you're asked to do. So I'm going to do something a little awkward, but it will give you something to do for this lab. I'm going to turn off the slope. And what I'm going to send you is this graph. And what I want you to do is to measure its slope. And then, of course, what you're going to be turning in is this data table where it says, do you have the plot? And then you measure the slope and determine the resistance of our first resistor. Okay? And so I'm going to send this graph to you, but without the slope. So you've got to measure the slope. And of course, hopefully I've already made it clear, but you have to realize that the slope is the resistance, and that's how you're going to get the resistance. So let me come over here and actually then get ready to send this to you. What I'll do is I will come over here to File, and where it says print graph, I will say, okay, I'm going to print the graph, but right here, instead of actually sending it to the printer, and our Adobe license, I'd rather do Adobe, but our license has expired. I don't know what that means. I tried that this morning. So I'm going to go to the Microsoft Print to PDF, since that one, I know our Microsoft license is good. And I am then going to print it to my desktop here. Oh. Did it print? And turn off a couple things that might be affecting it. But I know this worked well this morning, and now it seems to be non-responding. I don't think it'll let me do anything, but I'll try. I'm suggesting I print something here. Yeah, see, it says not responding when I try to click on anything. Well, bummer. But since as long as we're on video, let me just stop this and start it up again here. So, Control-Alt-Delete. Let me go to my Taskmaster. Till it let me. That's new. So I guess we got a couple of new things here. Let me do a force end of it. And let me restart. Interesting. Let me re-zero. Let me hit collect. Okay. And maybe I'll have to do this a second time here. Let me go keep. Keep. All right, so I'll just go up to about 5 again and hit stop. And looks like a nice straight line. And let me try this one then. So I'm going to try the same thing. Let me go File. Let me go Print Graph. Let me go OK. And let me go to Microsoft PDF. Let me go OK. And I didn't like that. Now let me give it a second. But normally, that would just come back and say, where do you want me to save it? But I think since I have us on video,
try print screen.
I'm going to Ron thinks I should print it. You said the printer's not on.
No, print screen to copy to the clipboard.
Well, okay, so maybe I'll do a print screen, alt print screen.
Now you have a graphics program you can just paste it into.
Yeah.
Paint.
Actually, I'll just go to Microsoft Word. Is it W or is it M? There it is, W. But last time the thing crashed when I did this, so let's see what happens here. That didn't crash. That's a good sign. So maybe it actually did save the PDF somewhere. And control paste. Yeah, still spinning. Well, here's I think the direction I want to go. I'll worry about printing these and get the PDF after I turn off the video. Let's do the rest of the data and get the video done here. All right, so I'm going to try. I can see it say it's not responding, so I think I got to start this one again. But let's do the next resistor. And I won't even worry about that. All right, so let me restart it again. Wait. Do the auto recovery. And so maybe it'll make it a little bit easier for me when I'm done here if maybe I just save this for a second. And I'll just put it on my desktop as quadruple A, I'll just call it that, and save it. All right. Now I want to run this all again. So I'm going to go ahead and hit collect, although before I do, let me change my resistor. All right. So the second value is the red resistor. And so without changing anything other than replacing the blue resistor with the red resistor, let me run this all again. Okay, so now that we've restarted it, I probably have to zero the probes a third time, so I'll zero those and let that re-zero. Then I will hit collect. I will erase all the old stuff and begin here. Okay, so I've got my reading that is fouled up. Let me re-zero it. Okay, so they both say 0. Let me hit collect. And then I'll just say I'll keep that first one. And I'll just turn up the voltage a little bit. Keep. And hopefully again you'll see this nice straight line. And then I will hit stop. And again, your job then is going to measure this slope. Because I would say again then for this second resistor, the red resistor, it too is following Ohm's law, right? I have a straight line, and that's what the theory says. Ohm's law said I should get a straight line with an intercept of 0 when I measure the current and the voltage, and sure enough, that's what I have. So I'd say yes, it does follow Ohm's law. And I would also then say I could measure this slope. Now, as long as I have you on the video screen, I'll go ahead and measure it once, but then I'll take it off and give you guys something to do in terms of measuring it. But there's the, whoops, I did the integral. I didn't want the integral. I wanted the slope. So let me turn off these integrals and take a look at the slope. So the slope, let me get the box out of the way, but you can see that, like I said earlier, it does follow Ohm's law, and it has a slope of 50.37. And so yes, that is a resistor. Yes, it follows Ohm's law. It is a different value. So again, coming to our worksheet, here's what you're going to be turning in after you've watched all these, is you can say, okay, resistor number 2, what is the slope and the intercept? And of course, you're going to hopefully put 0 for the intercept, and you're going to put a slope then of what you measure, which is around 50, and you're going to say, all right, so this does follow Ohm's law. Now let's go to the third and last part of this. The third and the last part is to look at the resistance from a light bulb. As you probably know, one of the simplest circuits we can do is to run electricity through a light bulb. And when you do that, they give off light. Okay? So, in this circuit that, again, you've seen over here in the diagram, I'm just going to replace R here in the diagram with this light bulb. Now, our connections for the light bulb are a little different, but just to be careful here, I'll say, all right, I will disconnect right here. If I can't, it's on there, good. So I'm going to take away that resistor, including the alligator clips, because I won't need those to hook up, the light bulb. So there's the light bulb, and I don't know if I should try to twist it so the light bulb is standing up. Maybe I will. But there is this whole circuit with the light bulb. And just to give it a little test, why don't I go ahead and turn up the voltage to about 5 volts, and that should begin to warm the light bulb. I won't go any higher than that. You'll see our light bulb's not very bright. It can handle more than 5 volts. But this will be enough to illustrate the point, because what the point is here is it says, go ahead and measure the resistance when the light bulb is hot, but also measure the resistance when the light bulb is cool. All right, so what I'll do is I'll turn it up to 5 volts, and while I'm talking, I've left it on. It doesn't take long, so a good 5 seconds, and that light bulb is nice and warm, so it's probably been about 5 seconds. I'm going to use the computer again to measure then the resistance at this particular point. All right, so let me come over here and hit, save. Thanks for reminding me there, Ron. So that I can come back and save this. This time I'll go BBB and put that over on the desktop. Okay. Oh, you know what? No, I want to get rid of the line. You guys are supposed to do the line. So I'm going to save it again without the line. Because that's what I want to send to you. Okay, so you can come up with the own line. Now let me do this last little experiment. It's got little 2 parts to it. Again, let me hit collect, and it will ask me if I want to erase the old stuff, and I'll say yes, and let's continue. And so right now it is very hot because it's taken me a long time to get here. Let me start collecting some data, so I'll hit keep. And I'm going to turn it down just a hair. But not so much that it begins to cool. So it looks like I've just collected 9 pieces of data when it is kind of on the cool side. In fact, you can kind of see in the graph it's over here. So let me just change the setting here so you can actually kind of see what I have here. So this right here, the slope of that would be the resistance when it is hot. So let me go ahead and make it cold. And maybe for starters, I'll just turn it all the way down and use what we call the fine button here to get maybe a little bit of voltage. It might be too little. No. And look here on the graph. Here it is. Maybe I'll even go a little bit lower. And let me take some data again when it's cold. So keep, 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 keep. And there's, oh, I did more than 9 there. But maybe I'll just hit a stop. But here's what we want you to see, that the resistance does change with temperature. And so if I come over here and I say measure the slope when it was hot, and over here measure the slope when it is cold, or I should probably just say cooler, because it does take a little while for it to cool down. You will hopefully see that when it was hot, I'm getting a slope of about 71.6. So I would say when that light bulb was hot, it had a resistance of 71.6 ohms. But yet when it was on the cool side, it had a resistance of only 42, I'll call it 0.8.